Welcome back from the break, everyone. We're now going to be continuing some more examples with regards to finding the values of A, D, Tn, and N for arithmetic sequences. Let's have a look at our next example together. So, we are given the arithmetic sequence 2x plus 4 minus 2x minus 3 and 3x minus 1. Before I go any further, I don't want you to worry. Yes, there are x's. Yes, there hopefully aren't your x's on my board because that would be awkward. But we are going to use your favorite, algebra, in order to work out this question. So before your brain goes, oh, no, can't do this, they're x's, let's see what's actually being asked of us and why there are x's in my actual sequence. Let's go back to the board. So we are going to determine the value of x for which these terms form an arithmetic sequence. So we're going to handle the x's first things first. So don't worry, we're going to get rid of those x's before you know it. Then B is asking me to determine the formula for the nth term of the sequence. Then C is asking me for the value of the 11th term. So, going into the part of the example where I need to solve for x. I've been given 3 terms of my pattern which involve expressions with x within it. But how am I going to solve for x? This just seems like a bit of a mission. Something that is going to help me is relying on the definition of what an arithmetic sequence is. We know that between the terms of an arithmetic sequence, there is a common difference. We are going to rely on the fact that there is a common difference in order to solve for x. Let me show you what I'm talking about on the board. So, between these 2 terms, if I were to calculate the common difference, we know that I can say term 2 minus term 1, and I can say term 3 minus term 2. So if I say term 2 minus term 1, I'm going to have negative 2x minus 3. Then I'm going to subtract term 1, which is 2x plus 4. If I simplify that, I'm going to have negative 2x minus 3 minus 2x minus 4, which can be simplified to negative 4x minus 7. So that's the first difference between the first 2 terms. Now we're going to look at T3 minus T2. I'm going to have 3x minus 1. Then I'm going to subtract term 2. Please make sure that you substitute your term 2 in a bracket. Why a bracket? Is because I do not want you to make sign mistakes. So we're going to subtract negative 2x minus 3. So I'm going to have 3x minus 1 plus 2x plus 3. So this is going to be equal to 5x plus 2. So we now have 2 expressions that still involve x's. How is this going to help me? Well, I know that it's an arithmetic sequence, which means that the common differences have to be equal to each other. We know that that is the main principle and the foundational concept and rule for arithmetic sequences. So we are going to equate both of the expressions together that express our common difference in terms of x. We know that the common differences have to be equal, so we're going to use that to solve for x. Let's equate them together. So I'm going to say that negative 4x minus 7 has to be equal to 5x plus 2. If you're asking me why, common differences have to be equal. So let's solve for x. If I bring the 5x over to the left-hand side, I'm going to have x. Then if I take positive 7, sorry, algebra mistake. If I bring the 5x over to the left-hand side, I'm going to have negative 9x. If I take negative 7 over to the right-hand side, I'm going to have positive 9. In order to isolate for x, I'm going to divide both sides by -9. So that means that x is equal to -1. I hope that everyone's still with me. So the main reason that I could solve for x's was for equating common differences and then solving for x. Let's have a look at the next part of the question. So we now need to determine the formula for the nth term of the sequence now that we know that x is equal to -1. We know that the nth term of the sequence comes in the form of Tn is equal to a plus n minus 1d. But I don't have a. A is still in terms of x. So what I'm going to do is I'm going to actually substitute in x is equal to -1 to find the value of term 1, term 2, and term 3, as this will help me find d as well as a. So all I'm doing is substituting in the x value that I found into each time or each place where I've got an x, because this is going to help me find the actual values of these terms. So 2 times -1 plus 4 will give me 2. -2 times -1 will give me +2. Minus 3 will give me -1. Then 3 times -1 minus 1 will give me -4. So I've now substituted in my value for x to find the actual values of term 1, term 2, and term 3. Because I now have the actual values of term 1, term 2, and term 3, I'm going to be able to find a and d and determine the nth term for this sequence. Let's work on a and d. So we've already said that the pattern goes 2, -1, -4. I know that a is equal to 2 because a is always equal to the first term of the sequence. I'm now looking for my common difference. We can see that between each of the terms, I've actually subtracted 3. But if I want to write this down in a more mathematical way, I can say that d is equal to t2 minus t1, which is equal to -1 minus 2, which gives me -3. I'm now going to substitute those values into Tn is equal to a plus n minus 1d, as this will help me find the general form of the sequence. So Tn will be equal to 2 plus n minus 1 times -3. If I multiply that out, I'm going to have 2 minus 3n plus 3. So Tn will be equal to 5 minus 3n. Okay, hopefully everyone's still with me. Substituted in the x values to find the first 3 terms. Then I proceeded to find the general nth term as normal. Cool. Everyone, smile. You're doing great. Let's carry on. Let's look at the next question. So we are going to now determine the value of the 11th term of the sequence. Because I'm determining the value of the 11th term, that means I'm going to substitute in n is equal to 11. It's not which term has a value of 11, it is the actual 11th term. So T11 will be equal to 5 minus 3 times 11. So that's going to be equal to 5 minus 33, which is going to give me that term 11 has a value of -28. Wonderful, guys. We are now going to move on to our next question. I hope that everyone's still with me. If you have any questions, please don't hesitate to ask your maths teacher, but please just carry on working with me, following with me, and we're hopefully going to get through this all together. Let's look at the next example. So, we are now told that the sum of the second and the 6th term of an arithmetic sequence is 4. The third term is 24 more than the 11th term. So this is kind of similar to an example we've done in the past where we are given certain pieces of information about a sequence, but we still don't know what the actual nth term of the sequence is. So for this question, we're going to determine what the nth term is. We're going to determine the first 3 terms of the sequence, and we are going to check if negative 72 is a term in the sequence. So for the first part, if I'm saying that the sum of the second and 6th term, the second term would be T2 and the 6th term would be equal to T6. So the sum of T2 and T6 is 4. When I say that the third term is 24 more than the 11th term, that means that T3 minus T11 would have to be equal to 24. Why? Because the third term is 24 more than the 11th term. So everyone, all that I've done is I've written down the sentence, but now I've written it mathematically using Tn values. Let's now replace those Tn values with expressions for A and D. So T2 plus T6 equals 4. We know that T2 can be written as A plus D. T6 can be written as A plus 5D. So all I've done is I've now written T2 and T6 in terms of A and D. If I simplify that, I'm going to have that 2A plus 6D is equal to 4. Now let's fill in for T3 and T11. T3 is the same thing as A plus 2D. Then I'm going to subtract T11, which is the same thing as A, plus 10D. And that is equal to 24. I'm hoping that at this point, everyone can see that I again have algebraic expressions or algebraic equations that have A and D. Because I have A and D, that means I'm going to be solving simultaneously for A and D. Let's get going with that. So I'm then going to divide everything by 2 on this left-hand side because that's going to give me A plus 3D is equal to 2. So A will be equal to 2 minus 3D. I'm going to substitute that across, but before I substitute it, let me just simplify this side. I'm going to have A plus 2D minus A minus 10D is equal to 24. And actually on this side, guys, we can actually see that our lives are going to be much easier because the A's cancel. So I'm going to have 2D minus 10D is equal to 24. So it's going to be negative 8D is equal to 24, which means that D is equal to negative 3. So I don't even have to take this A across because I know that D is negative 3. I'm going to take this D across to solve for A. So I'm going to have that A is equal to 2 minus 3 times negative 3. So A is going to be equal to 2 plus 9. So A is equal to 11. So if I'm determining an nth term or an nth expression for the sequence, I'm going to have Tn is equal to 11 plus n minus 1 times negative 3. So it's going to be Tn is equal to 11 minus 3n plus 3. So Tn is equal to 14 minus 3n. Let's look at the next question. So we now need to determine the first 3 terms of the sequence. That's found by substituting in n is equal to 1, 2, and 3. I'm going to then see that the first 3 terms are going to be equal to 11, 8, and then 5. So if you substitute in n is equal to 1, 2, 3, I don't have time to show you all the algebra, you'll see that the first three terms of the sequence are 11, 8, and 5. Last but not least, I'm asked if negative 72 is a term in the sequence, and we need to justify our answer. Guys, please remember that when I'm determining whether something is a term in the sequence, I have to actually see if I get a natural number for n. Let's see if we get a natural number for n. So I'm going to substitute in negative 72. And I'm going to isolate and solve for n. So I'm going to say that it's going to be negative, oops, sorry everybody, negative 86 is equal to negative 3n. Cool. Then if I divide by 3, let's look at our calculator. Negative 86 divided by negative 3 gives me 86 over 3. But this can't happen in a pattern because I have to have a natural number being a term number. I don't get a fraction value for a term position. So that means that 73 is not a term in this sequence. But otherwise, thank you so much for joining me today. I hope that you guys enjoyed the lesson, and I'm sure I'll see you again soon. Thanks. Bye.